we will talk about one very important point, which is called as collinearity. What does this collinearity actually means? If I talk about the assumptions, then we have line assumptions for linear regression. What does L stand for? We just seen. What does L stand for?
Linearity.
Linearity. And what are we saying in linearity? We're saying that y and x should be correlated. There should be a strong correlation. Y and the parameters should also have linear relationship. Very good. But what about x and x? What about x and x? We have y, x1, x2, x3, x4, so on and so forth. So we are looking at correlation between y and x1, y and x2, y and x3, y and x4. Fine. But what if we have strong correlation between x2 and x3? Then what happens? This is also something that we have to check, because ultimately it's a mathematical equation that we are writing. Okay, like this. I will take two columns. One is the years of experience that we looked at, right? Experience. The other column is age. Okay, now tell me, this is salary. Let me write salary as y. Okay, these are the three columns that we are looking at. This is my target. This is the first variable. This is the second variable. Now, we know that there is a correlation between y and x1. As the experience increases, salary increases. Right? This is something that we know. We also we can also comment saying that as age of a person increases, salary may increase. But it may not be very, very strongly correlated, because some people who are very old, they also get low salary because of the technology or because of the area of their work. Right? Years of experience is also something like that. But what is the relation between x1 and x2? We're talking about correlation here. Age and years of experience. When will your experience increase? When you grow old only, right?
As you grow. Yeah.
Right? Obviously, they are very, 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 very strongly correlated, isn't it? So if I have to quantify it, let's say this is R1, this is R2, and this is R only. Okay, just R. So if I say R1, it may be around 0.85, just for understanding purpose. R2 may be around 0.75. It is not that strong. But if I talk about R may be close to 99, 0.99, close to. They're very strongly related, isn't it? Now, what happens if I use these variables in the mathematical equation? What is this objective? What is the primary objective of this equation? If I draw like this, I'm getting a straight line. What is the primary objective of this line equation? I'll write only one variable. Yeah. So what is the equation's purpose? If I substitute x value into this equation, then I should be able to compute y. Right? The objective is to compute y. Target. So here I have two variables, okay? Just extending this into now this. Let's say I have salary, right? Age, experience, and age, right? So this is salary, this is experience, this is age. Now there is a person whose experience is 5 years and this guy is 35 years. Okay, this is something that we know, and the person has some salary. We have to calculate it. Now let's say there is, next case, the experience is treated as 6 years. So what could be the age of that person? Knowing this information, what could be the age of this person?
36.
36. This is something that we will be able to estimate, right? By applying the basic common sense. We can say that if the person is 5 years experience old and if the person has 35 years, then obviously as 1 year increases, the years of experience increase. That means age also has to increase by 1 year. So this is something I am able to tell. But what about the salary? Can I estimate the salary on the same lines? Let's say the salary here is $5,000, assume. What would be the salary in the second case? Given this information.
We cannot predict.
We cannot predict the salary with the same confidence that we are predicting or we are estimating age, isn't it? This is something we will not be able to gauge or estimate. So what is happening here is, in this equation, because of the strong correlation between these two variables, when I am substituting a value into this equation, the equation, this relationship that we are talking about is influencing the value of the other variable. Whereas this equation is supposed to explain the relation between x1 and y, isn't it? So this basically allows or should allow us to compute y with higher precision, more accurate y has to be calculated. But what is happening here because of this relationship? When I know x1, I'm able to influence x2. Why? Because of this interaction, the strong correlation that we see. So what should we basically understand from this is, when I'm trying to define the relation between the target and input variable, I need the input variables which are independent of each other. Okay, x1 should be independent of x2. If they are related, then I will not be able to give the equation which gives us more accurate results, because there is an internal interaction between them. Right? It's like duplicating the same information. Isn't it? It's like 1 year is increasing here, same 1 year is increasing here. Why I need both the variables to talk about the relationship here? The pattern here is same, right? Variations in the data here in x1 and x2 are same. I don't need both of them. I need unique input variables, independent input variables. Okay. So this problem that we are talking about is called as collinearity. And if you see pairs of them, for example, age and experience is something which we are talking about as a pair. But similarly, if you have multiple such pairs, then we call it as multi-collinearity. Okay. Now, what happens if I have this kind of collinearity pairs in the data? You are unnecessarily duplicating the information from multiple variables. And because of the interaction here, you would not be getting an effective equation which can help us to predict y. Okay, because of this interaction. So in such cases, we will identify which of these two have stronger correlation with y, and then remove the other one which is not impacting y that much. Okay, you remove them. One of them has to be used, not both. This is the best approach. Okay, whenever you see multi-collinearity, remove it. So there are two ways to interpret it. One is look at the R1 value, R2 value. Among these two, which is stronger, you retain that, and which is less, you drop that. So if x2 has less correlation with y, you drop that. This is one way to handle. The other way is VIF, Variance Inflation Factor. That's a calculation which is done And this VIF will identify the collinearity variables, correlated variables. Okay, the formula for VIF is 1 by 1 minus R squared. This is the formula. And it is said to have this as a threshold. If VIF is greater than or equal to 10, then we will declare that the variable is correlated or has collinearity problem. See, correlation is a good thing, but when it is between y and x, okay, this is called as correlation. If x and x are correlated, then it is a problem. We call it as collinearity problem. Okay, so VIF is used to detect the collinearity of this individual input variables.